So in this topic, we're going to discuss the idea of maintaining large amounts of data in a bit of a different way. Now, we've talked about regular variables, we've talked about arrays. In this one, we're going to talk about a two-dimensional array. Now, first of all, let's visualize how we picture an array. We usually picture an array in a nice row of data. And we have it like this, and then we separate each individual piece. And each one is an element of the array, and each one is numbered 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is a perfect array of size 10. So there's 10 total elements here. And let's say we call this array nums. And who knows what values are. Maybe they're just simple multiplication table. Maybe this is 0 times 10, which is 0, 1 times 10, which is 10, 2 times 10 is 20, and so on and so forth, all the way up to 90. Very simple array. And if we want to display that array, we would just write out a basic for loop. And let me just quickly do this. Let's say we want to go for int I is equal to 0. I love how it autocorrects. Is equal to 0, such that I is less than nums.length, and then I plus plus. Now, to finish this off, inside, all we would have to do is, if we were just looking to display this data, we just have to do a simple system.out.println and then the data itself. So let's say nums at I. Now that would display each individual value, 0, 10, 20, all the way up to 90, on its own row. If we didn't want it on its own row, if we wanted it all together on one row, we just say nums at I, and then let's just put in a space in between to buffer it out so we can tell the data between one another. This is a basic array. Now, you all know how this works. There's nothing weird here. But with a 2D array, what 2D does, two-dimensional, means that it has more than just a single row of data. What it actually is made up of is a grid of data. So our grid looks something much more akin to this. So we have, a nice box. Let's see if it autocorrects this box for me. Oh, it did. That's nice. And then the grid itself is made up of a series of rows. Oh, now it's correcting certain things. Crazy. Whatever. And each row is made up of columns. This is terrible. But in any case, we have our data. Anyways, so we have a series of rows, and these rows are numbered from 0, 1, 2, 3, 4, 5, 6, 7. So we have 8 rows in this case. In this case, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 columns. So when we define this, we say we have 8 rows by 9 columns. And if we want to refer to an individual element, it's almost like thinking about Excel. When we think about Excel, we have rows and columns. It's just a grid. Now, if I want to talk about, let's say, this element right here, that is at row 3 and column 4. So if I wanted to give it a new value, I would have to refer to both of those properties in order to make sure that the program knows exactly which element I'm talking about. That's it. That's all there is to it. Now, one thing I should mention, though, in Java does this a little awkwardly. So Java does not create a grid per se. What it does is it creates an array where every element of the array is actually an array. Oops, that's a terrible, terrible, terrible drawing. This is awful. Anyways, so each one is its own array within each element of the row, each element of the original row. But there's no point in thinking about it like that. That is actually how it's stored, but in reality, this is how you're going to envision it. So let's go see how we do that in code. The good thing is it's pretty straightforward, relatively speaking, to an original array. So just here, I have a quick little program that creates an array called nums, which has 10, and it does exactly what we did on the previous example. It takes each value and multiplies it by 10. So the element of I, so it takes its index and multiplies it by 10. So when I is 0, 0 times 10 is 0. 1 times 10 is 10. 2 times 10 is 20. All the way up to 9. 9 times 10 is 90. And so that's how it populates the array. And then to display it, I just go through each element and display them one at a time, adding the space for readability. And so if we run this, and we run it down the bottom, we see a nicely laid out setup. So we have 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. That's great. Now let's do it in 2 dimensions. So what I'm going to do is I'm just kind of going to go below this so we can see the difference here. I'm just going to kind of block this off so we know the difference between the two. Now when I want to create a 2-dimensional array, I do it in pretty much the same way. I just have to specify to Java that I'm actually doing it with 2 dimensions instead of 1. So we're still going to do an int array. It is an array, but now it's 2 dimensions, so I have to put the square brackets twice. The name I'm going to give it, I'm just going to call it numsGrid, is equal to a new int. Again, it's 2 square brackets. Now this time I have to specify 2 sizes. Up here I just specified the number of elements. Now I need to specify the number of rows and the number of columns. They do not need to match up. It does not have to be a perfect square. You could have 10 rows and 5 columns, or 2 rows and 100 columns if you wanted. It's up to you. It depends on what you're doing. So let's say, for example, you're creating I don't know, some type of scoreboard or something like that. You might just have an array of scores and then position values or something like that. I don't know. Anyways, so for our purposes, we're going to keep it simple, and we're just going to make it 10 rows by 10 columns. So we've created our grid. Great. Now we need to populate it. We're going to populate it the same way that we populated this one, but we have to do something a little bit more special. We have to think about how we're going to go through every element. If I just did a for loop, I did this. If I just said for int I is equal to 0 such that I is less than nums grid dot length I plus plus. First of all, you have to think to yourself, which length is that giving me? Is that giving me the number of rows or the number of columns? I don't know. Well, in actuality, it's giving us the number of rows, the first setup we specified, in this case 10. So if this were a 5, that would mean we have 5 rows, so numsGrid.length would give us a value of 5. We're just going to put that back to 10 for now. So this will go through every row of the grid. So looking back at our diagram, it would go through all of these rows, one at a time. But we can't look at a whole row at a time. We need to look at individual elements. So that means for every row, we have to look at every individual column. So for row 0, I want to look at column 0, row 0, column 1, row 0, column 2, row 0, column 3, and so on and so forth. So what that means is we need to use a nested for loop. For int j is equal to 0 such that j is less than numsGrid. Now this time I need to specify that I want to know the number of columns. Well, the easiest way to do that is, because remember it's an array of arrays, give me the first array element and tell me how long that one is. That will tell me the number of columns. And then j plus plus. And now we can work from there. Now I'm going to change the names of these variables just to make them a little bit more clear what they represent. So from now on I'm going to call I row. And I'm going to call j column, or col for short. And now we can clearly see what they represent when we're actually using them within our program. So now what I want to do is I'm going to create a multiplication table. So it's going to go from 0 to 9 and 0 to 9 because it's the array is 10 by 10 and it starts at 0. So I'm going to go from 0 to 9 by 0 by 9. So it's just going to be a multiplication table, which means every row is multiplied by every column. And I'm going to so somewhere I'm going to have this calculation. And I'm going to assign the result of that into the appropriate element of the 2D array. So somewhere numsGrid something something is going to equal that. Well, the something something, which one, which row, which column? Well, whichever row and whichever column we're currently on. So if the row is 0 and the column is 0, that means 0 times 0 gets put in the top left corner of our grid. 0 times 0 would go right here, 0. Then we'd go over to the next column because we're inside the second for loop. So row 0, column 1. Well, 1 times 0 is, well, still 0. So 0 would get stored into that element, and so on and so forth. That's it. That's all we need to do to populate the entire array. Great. Just a multiplication table of row times columns. There we go. So let's display it. The good thing about displaying is it's pretty much the same as populating it. So we're going to copy and paste this 2D array, or this, sorry, not this 2D array, this nested for loop. We're going to put our brackets in there. Oops, an extra bracket there. Where is he? There we go. Okay, so what do I need to do? Well, I need to do the exact same code that I did up here. System.out.println. But, sorry, .print. I don't want just nums at I want nums grid. And I don't want I want row. Not only that, I need to know which column as well. So I'm going to output one single element where the row and the column intersect. So 0, 0, 0, 1, 0, 2. Remember, it goes for every row, look at every single column. Then go down to the next row. Every single column. Then go down to the next row. So if I were to display this right now, we would see something. It wouldn't be super pretty, but we would see something. Everything's just in one big, endless row of data. Not exactly user-friendly. So what I want to do is at the end of every row, because I'm using print and not println, there's no way for it to go down to the next line. So after a full set of all the columns, I want it to go down to the next output line for the next row. So here I'm going to say system.out.println. I'm just going to output a blank line. So you see, just with that one change, we get a hugely big difference. Now we can actually see the data. Now it's still pretty misaligned. We still don't know what data is what. And it's pretty ugly in terms of alignment because these single digits. So let's force those single digits to 2 digits. That's easy enough. If the value is less than 10, then let's just force an extra 0 in front. So all we have to do is check to see the value of nums grid at row column. So if nums grid at row comma column is less than 10, then we need to make it 2 digits. So what we're going to do is we are going to just why am I getting an error on that line? Oh, there we go. If nums grid at row comma row column is less than 10, then I want to display a 0 and then display the rest of the number. System.out.print, print, not print line, 0. And now what you'll see is things start to line up. Now that's much cleaner. We can actually see a multiplication table there. Well, let's add a little bit more. Let's make it even just a bit prettier to make it cleaner to look at one more time. Let's add in some headings to each row and each column. So at the beginning of every row, I want to display, hey, what row number are you on? So system.out.print, again, not println. I'm going to display the row number. I'm going to concatenate that with some just some display, some text so we can see what's going on. Again, we run it again, and all of a sudden, again, it looks that much prettier. Alright, we got all the rows. Now let's add the columns. Now, we're just going to force this, because to be honest, you could do it inside of the same place, but like at the end of every column, but it just adds more complications. It's easier just to display a single line before the whole double for loop. System.out.println. Now, looking at the layout here, how many spaces do I want, and then the numbers 1, 0, 1, 2, or 1, 2, 3, 4 all the way to the end. So I'm just going to put out, I think it's probably, I don't know, 3 spaces, and then a 0, and then 2 spaces to 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's it. Now if we output this, that's off. So we need to add in, let's say, 2 spaces right here. Run it again, and now we have cleanliness. Perfect. We have our nice multiplication table. We know exactly what lines up with what. So 0 times any one of these is going to give me 0. 1 times each column is going to give me the proper value. So it's just a nice perfect multiplication table. So that's how we can use our 2D arrays. Now what you need to realize is that 2D arrays aren't just for integers. You could store anything as long as they all match the same type. You could have an array of 2D array of rectangles. Or let's say, for example, you're making a game like Minesweeper. Maybe each element is like a string that represents what's on that cell location. Say, for example, a 4 telling you that there's 4 bombs touching that one place. Or maybe it's a bomb itself. So it's up to you how you go about using this data, but it is a way for you to organize large amounts of data in a very clean way.